Hello guys, good morning to all. Today we will see the topic Lorentz force, the force on a conductor in presence of electric and magnetic field. That force is known as Lorentz force. The force experienced by the charged particle moving in a space where both electric and magnetic field exist is called Lorentz force. So whenever a charged particle is present, as you know that in the charged particle is experiencing the electric field, and electric field will apply the force on that charged particle, and the charged particle will automatically produce the magnetic field, because you know that whenever there will be electric field, automatically magnetic field will generate. So that magnetic field will be experience a force by this external magnetic field. So that force is known as Lorentz force. Now the first of all, the force due to electric field will apply the force F is equals to QE. Here Q is the charge and E is the electric field, so Fe is the force applied by the electric field, that is equals to QE. Similarly, the force due to magnetic field Fm means force due to magnetic field, that is equals to Q into V cross B. Here V is the velocity, B magnetic field, and Q is the charge. And if you will calculate the total force due to this electric field and magnetic field, what we will do, we have to add Fe and Fm. So F is equals to Fe and Fm. When we add this, we will get QE plus QV cross B. So here QV should take common, and E plus V cross B. So F is equals to Q E plus V cross B. This force is known as Lorentz force, or the force experienced by a conductor in presence of electric and magnetic field both. Now we are having some cases. For example, the case number 1, when V, E, B all three are collinear, means all three lie in the same line, then at that time the charge experience the particle, the magnetic field force due to magnetic field is 0. Why it is 0? Because cross product is here and cos theta 0. So when the cos theta V cross B, so cross product should be 0, and the overall answer due to magnetic field force will be 0. So net force is due to the electric field, and the F, and you should calculate the acceleration. A is equals to QE upon M, because F is equals to MA, so A is equals to F upon M. So F is here QE, so QE upon M. Now the second case, when the V, B, E are mutually perpendicular to each other, at that cases the net force due to Fe and Fm is equals to 0. So if it is 0, that means electric field and magnetic field force will be equal to each other. Okay students, now we will see the next topic. Now students, our next topic is force between the two parallel linear conductor carrying current. Now here we are having the two conductor, one is here, one is here. In the same case, in both the cases, here both the current will be moving along the same direction. So one wire is here C1 D1, and another wire is here C2 D2. This current on the wire C1 D1 is also produce a magnetic field, and C2 D2 also produce a magnetic field. So both the magnetic field will interact with each other, and due to that some force is experienced by the conductor. So this conductor also experience the force due to the magnetic field of this wire, and this wire is also experience the force due to the conductor of this. So here we will see what is the magnitude of the force experienced by both the conductors due to their magnetic field. So consider here C1 D1 and C2 D2 are the two infinitely long straight conductor carrying current I1 I2. I1 I2 current is here in the same direction. They are held parallel to each other, and distance is R between them. R distance between the two wire. Due to the magnetic field produced due to the current through the each conductor shows separately each other experience a force, and both the wires experience the force. The magnetic field at the point P due to conductor is C2 D2 due to the current I1 current experience produce a magnetic field, and that magnetic field will apply the force on this another wire C2 D2. Now so B1 is equals to mu naught upon 4 by 2I upon R. And similarly, therefore the unit length C2 D2 also having the force F2 is equals to B1 I2. Okay, now put the equation 1 into 2. So F2 is equals to mu naught upon 4 by 2 I1 I2 upon R. So it is the value of the force experienced by the second wire. According to Fleming's left hand rule, one conductor C2 D2 act perpendicular to the plane of the paper in the direction of C1 C2 are the same for the C1 and D1. So directed toward the C2 D2. It means it will parallel conductor having the same direction will attract each other. The force experienced by both the wire here, they will attract each other if they are having the same direction, and if the wire is having opposite direction of the current, then they will repel each other. So here the net force formula is mu naught upon 4 pi 2 I1 I2 upon arm. So this force will experienced by this wire at the same time. Due to this wire, it is also experience the same force. So force of attraction or force of repulsion depend on the direction of the current. If the same direction, then it will be attraction, and the opposite direction of current will flow, then it will be repulsion. And the magnitude of the force is mu naught upon 4 pi 2 I1 I2 upon r. Both the current are distance between them mu naught upon 4 pi. Thank you. In the next video we will see some more topic.